Hello everyone, in this tutorial we're going to make a simple platformer game. So the first thing you need to do is navigate to clockworkchili.com/Wade. So now that the editor's open, we are just going to click skip tutorials. We're going to click new project and we are going to call it platformer. There we go. So now we are going to have an empty project, but we need some art to work with. And I've already downloaded this just because it takes a little while, but I'll show you how you would do it. So you'd click on the smiley face and you'd log in. So for me, that is tutorial at clockworkchili.com. Enter your details and click login. Login successful. Excellent. So now you need to click on the shopping basket to go to the shop where we're going to download some free art. Now the two things I'm going to use for this project can be found in art. And the first one is in backgrounds. We scroll down to the second page and we click on free landscapes. And we just go ahead and download that. Then we go back to art, humans, click on Gaia. And we are going to download her too. Now those will take a little while to download, so I'm going to use the ones I already have. Once they've downloaded, you can just drag them straight into your project. So I'm just going to go away from there. I'm in the wrong folder. Downloads, there we go. So the landscape, I'm going to use this landscape. It looks nice. We'll just drag it in. Back to downloads. And we also need the Gaia walk animations. Now I'm using her idle walking animations and her jumping flip animations. So I've got all 6 of those. So we've got 2 idle facing left and right, jumping going left and right, and walking for both left and right. I also have a jump button, a star, and a platform, which I made myself. So I'm just going to drag all those files in. So now we've got all the art in our project, we can see here. First thing we're going to do is create the background. Now first of all, this background image is huge, so we want to resize it. We're going to resize it to 1280 by 720. And we are going to put it on layer 5 because we want it behind everything else. So the next thing we need to do is we want to name our background just to keep everything nice and consistent. So we go to properties and we call it background. Now I'm going to go to the scene properties and lock the size to 1280 by 720, just so it's the same size as our background. We don't have any complex sizing issues. And we'll leave the default layer at 1. So now we have a nice background object. The next thing we need to add is a character. So I'm just going to choose the idle image of our character facing right. And she's a bit tall, so I'm going to shrink her down a little bit. That looks okay. In fact, we'll just quickly run to see what it looks like. There we go, that looks okay. So once again in properties, we're going to give our character a name, and for simplicity we'll just call her character. Now, the character has a lot of animations, so we need to go through and add all of those. And this might take a little while to do, but once it's done, we never need to look at it again. So we click on new animation in the sprites tab. And we're going to go through these all. So we're going to add the 2 idle animations first. So we'll call this idle right, and we'll set the image to Gaia idle side right. And that's all we need to do. Apart from for this specific animation, we're going to click active because it's the first way she's already facing right. We're just going to make sure that is the active one to begin with. So now we need to add idle left. So again, create a new animation, name it idle left, set the image to Gaia idle side left. So those are the 2 easy ones. Now we need to add the walking animations. So similarly, we're going to keep a consistent naming scheme. So walk right, then we select Gaia, walk side right. The only difference in this one is we need to select loop, because our walking animation will be looping. And we also need to check the animation is the right size. And that looks like a 4x4 image, so we need to change cells to 4x4, so there are 16 in total. And we need to do exactly the same for walk left. So let's go ahead and add that now. Walk left. And we choose Gaia, walk side left, loop, cells 4 and 4. Excellent. So now we just need to add the jumping animations, and in this case the jump is actually a flip. I thought it would look cooler if she was doing a flip, but we're still going to call it jump just for simplicity. So jump right, that's what we're going to name it. Again, we select the image, Gaia, jump, flip, side right. We're not going to loop this one because once she's done her flip, we don't want her to do multiple flips in midair. It's going to get very confusing. And for this one, the cells should be 6 by 4, and the range should be 22 because the last cell in the picture is actually blank, so we don't want to display that. And the final animation is jump left. So let's just call it that, jump left. Gaia, jump, flip, side left. We don't want to loop, we want 6 by 4 cells again, and the range at 22. So now we have added all our animations. The next thing we need to do is add some custom properties to our character. Now these will come in very important later on, but we're just going to write them now so they do not disappear on us. So the first one is action. So the character can either be standing or jumping. We're using jumping. Basically, if the character's in the air and not touching a platform, we will change her action to jumping. So for now, she's standing. We add another property by clicking append. We need to set the direction, and currently she's facing right. This will just be useful for choosing which animation we need later on. And we append one final property called platform. This will store the name of a platform that she's collided with. So if she's currently on the ground platform, for example, it'll store it in there and it will make our collision detection and everything much easier later on. But for now, we're just going to set that to null because she's starting off just above the ground. So I'm just going to go ahead and save our project. Now, I think we need a jump button on here. We need some way to tell the character actually jump later on. So we're just going to go and drag that in. We're going to resize it, make it a bit smaller, and just put it in the bottom right. That looks okay. We're going to rename it to jump button. There we go. And we're actually going to put it on the same layer as the background. The only reason I'm doing this is so it's not picked up later on in the collision detection. We only want to collide with things on the same layer as ourselves. And obviously we do not want to collide with our jump button. So I'm just going to move that to layer 5 and make sure it is the last item added to the scene, because if we put it behind the background, it will disappear as they are on the same layer. So it's just got to be in front of the background. And that should be quite simple. And also, we are going to go to functions in the jump button. We're going to go to on mouse down. And we're thinking ahead here where we don't have the functionality for jump yet, but we're just going to add this in now. So we can do wade.get scene object. And we pass in the name of the character, which is just character. And we just call the jump function. Now remember, character does not yet have a jump function, so this will not work. But I'm just writing it there so I don't forget to do it later on. Okay, so we need a goal in this game, and that is going to be to collect the star. So I'm just going to drag my star in here. It looks quite nice. And we're just going to go to properties and rename it to star. We're also going to go to custom properties, and we are going to add one called isStar. And we're going to set that to true. This will just help us differentiate between stars and platforms later on in the collision detection for our program. Now the last element we need in our scene is a bunch of platforms really. We need some way to get up to that star. So we're going to create one, and we're going to give it a similar isPlatform flag. So I'm just going to drag my platform in. I'm going to resize it because that's quite big. That looks okay, I think. So we want to set our flag, and let's just call it platform first actually. So platform 1, add our flag, and we'll just call it isPlatform. And we'll set that to true. So we need multiple platforms. We're just going to go ahead and clone them and then rename them all to keep everything nice and neat. So we press this button up here, duplicate object, or Control D, and that will create a new object. And I'm just going to drag these, I'm going to space them quite evenly. So these are just steps that the character can jump on to go up to the star. I'll just create a few more. And one more. I'm just going to space these out a little more evenly so it looks a bit prettier. Let's move that there. In fact, we're going to move the star a bit as well, just to make it easier. If you were making a full game, you'd spend a lot more time on this, but we just want to get something up and running quite quickly, so we're just going to do it like this. Now you'll see we've got all these platforms. I'm just going to go and rename these to platform 1, 2, 3, etc. Just so it looks a bit neater, because I like to keep things nice and tidy so we know where everything is happening in our code. So I'm just going to rename all of that to platform 5 and platform 6. So we'll just go ahead and we'll save that. So now we need to give our character the ability to move. So that's quite simple to do. We're going to click on our background object. We're going to go to functions. We're going to go to on mouse down. So the first thing we need to do is get a reference to our character. So we're going to create a variable called var_player. And then we're going to do way.get scene object. And we pass in the string of the object we want, which is in this case the player character. So we just pass in character. And now we have a reference to our player. So we want to move the player whenever there's a mouse click, which is fairly simple. So we need to do a move to function, but first of all we need to know which direction are we going to go. Are we going to be going left or right? Because we need to change our walk animations. So we need to check if the player's position is bigger or smaller than the X position that we get from our on mouse down function. So if player.getPosition.x, I'm just going to drag this window out so you can see it a bit more clearly. If that position is greater than data.screenPosition, this is the X position of the mouse click, then that means we need to move left, because we are currently to the right of where the mouse click happened. So we do player.direction is equal to left. Otherwise, the only other possibility is we need to move right. So player.direction equals right. And now we can set our animations, and we can actually do it in the same code here. So we're just going to go ahead and do that. We're going to do player.getSprite play animation, and in this case it's going to be walk left. There we go, nice and simple. Other thing we need to do is just copy and paste this into our else and change it to walk right. Excellent, so now the animation will display correctly. We still need to actually move the player. So let's go ahead and do that. We'll do player.move to, and then we need to get the new X position, which is just data.screenPosition.x. We will keep the Y location the same, so that's just going to be player.getPosition.y. And we're going to set the velocity at about 200. That should be pretty reasonable, I think. Now, another thing we need to quickly check, and we need to check at the start of all this, just after we get our reference, is the player jumping? Because if the player's jumping or they're in midair, we don't want to give them a command to walk left or right, because you can't really walk in midair. It doesn't quite work as you would expect. So, if player.action is equal to jumping, we're just going to return true here and ignore the input. There we go. So that's all we need to do in our on mouse down function for the background. And we're just going to play and test this actually. So yes, indeed, our character can walk. Notice though she keeps walking once she reaches her destination. That's because we're not stopping the animation. So we need to go into our character. And we need to go to the onMoveComplete function, which is down here. So in onMoveComplete, we need to check her direction. So if this .direction is equal to left, we need to change her animation to the idle left animation. So this .getSprite play animation, and then we just enter here idle left. Just going to check that's actually the name of it. So to do that, we can just go to sprites, idle right and idle left. Excellent, it is. And then we can just copy the inner part of this loop, because of course if she's not moving left, she has to be moving right. So we just then change it to idle right. We just go ahead and save that, and we will run our program again. And this time when she's moved to her location, she stops the animation. Excellent. So now we can walk left and right correctly. So now that we've got our character able to move, we need to go to her onUpdate function. And this is basically going to be the core of our program. There's going to be a lot of code in here, so we're going to go over it slowly. And there's a lot of things we need to do, but sticking on the movement theme, the first thing we need to do is make sure she can't move off the screen. Now that's unlikely with the clicking to move, but when she can jump, it is possible that she could jump off the screen. So that's the first thing we are going to check. So I'm just going to write a comment here, keep character on the screen. So now we need to add our conditional statements. So if this dot get position dot x is less than negative Wade dot get screen width over 2, that means the character is off the left of the screen, which we don't want. We want her to go to the limit, which is actually the value of minus Wade dot get screen width over 2. So if that happens, we just need to do this dot set position. Then we set her position, her x value to this. We just paste that in there. Ooh, we don't miss the minus. And her y position is just going to be what it always was. So this dot get position dot y. Likewise, we need to have an else if, sorry. And we do this for if she's off the right of the screen. So in this case, oops, can't seem to undo that. There we go. I just pasted that in the wrong place. You need to put it in the brackets. We need a greater than sign and remove the minus. So now if she's off the right of the screen, she's bigger than the highest x coordinate, we need to do the same thing. So we can just copy this set position function here. We need to remove the minus, but everything else will remain the same. So now we've ensured our character is on the screen. So we need to get the overlapping objects that we can collide with. So the overlapping objects function, as in previous tutorials, it will return any objects that have sprites overlapping with your object's sprites. So we're just going to create a variable called var overlapping, and this is just going to be an array of any objects that we happen to be overlapping with as our character. We do this dot get overlapping objects. Oops, I need to spell it right. Overlapping objects. And we just have empty brackets. We could put parameters in there, but we don't need to, as by default it only searches the layer your character is on. So now we've got that. We're also going to create a little flag, and we're going to call it collision happened equals false. This will be useful later on, because if there are no collisions, it implies our character is in the air. She's not touching any platforms, which means she should be affected by gravity. So now we need quite a big for loop. Now this for loop is going to iterate over every object in our overlapping list. So while I is less than overlapping dot length I plus plus, and later on after this for loop we will handle a case where there are no overlapping objects. So we're checking every object that we are colliding with, and the first thing we need to do is check that we're actually moving down. Because in this game, we've made the rule, it's just part of the game mechanics, we've decided that you can jump through a platform, but once you're above it and you fall down, you should land on it. So you can jump from underneath, but you must be able to land on the platform, obviously. So we need to check that the character's velocity on the y-axis is positive. So we do if this dot get velocity dot y. So if that is less than 0, that means the character's actually traveling up, and we don't want to have any collisions in that scenario. So we're just going to put a continue statement here to check the next object. Although actually thinking about it, I think we can put a break in here, because if we're traveling upwards, it's not going to be a problem. We don't need to check any other platforms. However, there is still the star, so really, I think we'll keep it in. We'll keep it in for now. We'll keep it simple. So it's not as efficient as it could be, but we're just playing it safe. Okay. So now, if our character is moving down, we need to do the next thing. And actually, I just thought we needed to, first of all, check if this is a star or a platform. We missed that out, I am sorry. So I'm just going to go up here. First, let's check if this is a star. So in our overlapping object, the only two things it can possibly overlap with is the star or a platform. And that's because they are both on layer 1, the same as the character. So first of all, we check if there's a star. Overlapping is star because that is what the property is for. So if it is a star, we want to do Wade.clear scene, as that is our game over condition. We finished the game, and we'll just put a break statement there too. So I'll just put a comment. We have got the star, game complete. So that's that. If it's not a star, we need to check if it's a platform. So else if overlapping, can't spell overlapping correctly today, of overlapping I.is platform, then we need to do all this code. So I just need to cut and paste this into here. That was just a little error. Just going to move that along. Great. And this makes more sense because we would want to collide with the star whether we were traveling up or down. It would not make any difference. So now we are in our platform collision code. The next bit we need to do is a little bit complicated. We need to work out what depth we are into the platform. So I'm just going to try and demonstrate this. I can't really explain the code amazingly well. It's a little complicated, but I'll show you by dragging the character. So if the character is here touching the platform, we want this to register as a collision. It would make sense. I mean, it looks like she should be standing on it, so she should, very simply. But there's a case where how far do we allow the character to sink into this platform before we say, well, actually, what really happened is she jumped and she didn't quite make it. She got to here. So that's what this depth calculation is going to say. If the depth value is very small and it is positive, it means she's above the platform and she's not too far indented into it. Now, I've just noticed actually the character's showing behind the platforms because they're both on the same layer. So I'm just going to drag her down there, and now she's in front because she's been added to the scene after the platforms. Okay, I'm also actually just going to add my jump button down there as well. So we've just reordered our scene a bit. But anyway, this depth calculation, to do it, we need to create a variable, var depth, equals, now we're going to get the height of the character sprite, so this dot get sprite dot y over 2, and to that we are going to add the height of the platform, so overlapping I dot get sprite dot y over 2. So that gives us the separation between them when both sprites are touching, basically. So when there's no gap between the bottom of the character sprite and the top of the platform, that's what that distance is. So from that, we are going to take away the y position of our platform, overlapping I dot get position dot y, and then we minus from that the y position of the character, and this will return the depth we are into the platform. Okay, shouldn't click off the character there because it leaves the function, so we just go back to our onUpdate function. Okay, so now we have the depth value. We need to do something with this. So like I said, we want kind of a threshold value here. If the character's too far deep into the platform, it probably means she actually jumped from under it and didn't quite make it. So I'm just going to have a small threshold value. So if depth is greater than 20, so if the separation is greater than that, we want to continue, there's no collision, she's probably jumped from underneath and not quite made it. So I realize that's a bit complicated, but experiment with the values. You can change the depth value and you can see how it behaves. So if we get this far, we probably have a collision. So we'll just write probably have a collision here as a comment so we know whereabouts we are. And I'm just going to save our code so far. And now what we need to do is set the platform that we've collided to. So this is the thing. If we are already colliding with the platform that we've just collided with again, we don't want to apply gravity. We don't want to move the character down when we're standing on a platform. So we need to do some little bit of logic here. So first of all, we need to check, is the platform that the character collided with last frame same as the one it's colliding with this frame. So we can do that by equals equals overlapping I dot get name. So that returns the name of this platform. If they match, we just want to continue. Now a collision has happened, but we don't want to continue and do the gravity part of this. That is not really what we want. Now just before we do this check, we actually want to change the state of our collision happened flag. So here we put a collision happened equals true. This will disable the gravity later on once we add that to the code. So a final thing we need to do is set this dot action equal to standing. So we're no longer jumping. Excellent. Now, of course, if this platform is not the same platform, so we've actually jumped from the ground, say, onto the first platform, we need to set this platform variable to the name of the overlapping object. So we just copy that, but this time we only have the 1 equals because we are assigning a value, not checking for a comparison. Now, the next thing we need to do is set the velocity to 0. So we just do this dot set velocity, and we pass in our object with x and y values. X is 0, y is 0. Very nice. But we also need to set the position, because we may be slightly into the platform at the point we disabled the velocity. So we need to do this dot set position. This is where our depth calculation comes in. So the x value will be the same. So we just do this dot get position dot x. Then we do this dot get position dot y, but we minus the depth from it. So that should have us standing on top of our platform. Excellent. Now the final thing I think we need to do, I just need to check this, it's looking good to me, is we need to change the animation once again. So we need to switch to the idle animation. So we need to get the direction our character is facing. So if this dot direction is equal to left, then we need to set the animation. So this dot get sprite, play animation, and we need to do idle left. And of course, once again, we can just have an else here because the only other option is idle right. And we just change the name in here like so. Okay, so this should be all of our onUpdate function. There might be some bits missing, but we can always come back to it and have a look if we have any problems. Now, we need to handle the case where there are no collisions, and there are two things we need to worry about here. So if there are no platforms colliding, so if overlapping, this is our array of objects, remember, that we are colliding with. If the length of that is 0, which means we're colliding with no objects, we need to set some flags. So this dot platform, the platform we're currently colliding with, is equal to null because we're not colliding with any. It's fairly simple. We also need to check our collision happened flag. So if our collision happened flag is false, that's what the exclamation mark means. Without that, it would be if collision happened is true. But with that, it's false. It's just shorthand rather than writing collision happened equals false. We need to change the gravity in here. So if collision happened is false, we want our character to be affected by gravity. So what we can do here is set the velocity. So we do this dot set velocity, and for the most part it's going to be the character's current velocity. So we just need to get our x and y parameters in here again. So we can do this dot get velocity, dot x, and this dot get velocity dot y. But to that we're going to add gravity, and that's just going to be, we're going to go with 15, just a small value that we increment our gravity by. I do believe that looks correct. I'm just checking. Is that all right? Collision happened. I think this is all good. Another thing we need to very quickly do, if a collision doesn't happen, that means we must be in the air, so we need to set our jumping flag. So this dot action equals jumping. Very good. And of course up here we've got this dot action equals standing. So I think that is all we need to do in the onUpdate function. It looks pretty good to me. So we're just going to save that. And the last thing we need to implement is our jump function, because at the moment our character cannot actually jump. So we are going to click Add Custom Function, and we are going to call it Jump. If you remember, in our Jump button, we added a call to this function, and now it exists. So the first thing we want to check is the character already jumping? So if this dot action is equal to jumping, we just want to return true because, alright, we've acknowledged the jump command, but we're already in the air. We shouldn't be allowed to jump again once we're airborne until we land. So we're just going to return true there to keep it simple. Of course, if we are not jumping, we want to change our action to jumping. So we just go ahead and set that. We also need to clear our platform flag. So this dot platform equals null, because if we jump off a platform, we are clearly no longer on it. So we don't need to store its name. And we need to disable any moving of left and right that may be going on from a previous click on the background layer. So we do this dot stop moving. Excellent. Now we actually need to calculate the jump impulse. So we create a variable called impulse. And this is going to have x and y properties or parameters, whatever you prefer. And x is the complicated one. I'm going to say a value of about 200, but it depends which direction we're facing. If we are jumping to the right, I want the x velocity to be positive 200. But if we are jumping to the left, I want it to be negative 200. And I'm just going to handle that. Oops, just pressed enter there. I'm going to handle that with a ternary conditional that I described before. So we're going to take this 200 value, and we're going to times it by either -1 or +1. That will get us our plus and minus 200. So to do that, we do this dot direction, which we know. If that is equal to right, that means we need a positive 200 value. So we return +1. If it's not, we return -1. So that will get us the correct x direction that we need. As for the y, that's just very simply, but -500 should do. Just a jump, we just need a positive a negative y value to jump upwards. Now we just need to do this dot set velocity and apply our impulse. So we can just pass that in because velocity expects an object with x and y, so that's very simple. Now the final thing we need to do is set our animations. So again, we just do this dot direction. If it is equal to left, we can just do this dot get sprite dot set. Sorry, I always do that. Play animation. The animation's already set. We just need to play the one we want. And this is jump left, I do believe. So jump left. And of course, the alternative, else, we just want to do jump right. Excellent. So I think that's our jump function completed. So we are just going to go ahead and run our project to see if it works. So we click run, and the character falls through the bottom of the screen. The reason is there's actually no ground to collide with. This is just part of the image. So what we can do is we can select one of our platforms. We can clone it with the duplicate button. We're just going to move that down to ground level, and we're going to make it a lot bigger. So now we are just reusing our basically collision code for platforms for our ground. Of course that looks a bit ugly, so we're going to go to sprites, and we are going to select visible to false. So the collision will still work, we just can't see it. We're also going to go ahead and rename that to ground. So, and we'll save our project. So now, if we try to run our project, let's see what happens. Whoa, we get lots of scrolling craziness. The log is going crazy. Sprites have invalid coordinates. Well, that's not good. Let's have a look. Let's just check the properties of our character. Actually, that's a bit dodgy, but I don't think that's causing it. She should really be classed as jumping because she's starting in midair, so we'll just go and change that and save that. But it's probably something in her onUpdate function, so let's just go there and see if we can spot anything obvious. But I mean, if it says the sprite coordinate is invalid, it probably means we're setting the position wrong at some point. So that looks good. Scroll down. It's... Oh, that's not good. I'm just doing get sprite.y. That's actually not correct. We need to be doing this dot get sprite, get size dot y. That's better. Actually, this doesn't... Yeah, I need to... Let's make this a bit bigger, this window. Yeah, I've done the same thing here as well. That's why we were passing essentially function names into this, so we wouldn't be getting a number, and that'll be breaking everything. So we just need to change this to get sprite dot get size dot y over 2. So that looks good, but also I think this is supposed to be in brackets because we want to subtract the actual difference in positions between the two objects, not subtract one then the other. I think that's right. Of course we could just add that, but no, yeah, we'll keep the brackets. I think that is the better depth thing. So just to reiterate, we've changed it to this dot get sprite dot get size, so it was the get size that was missing, and we've put in brackets around our code to work out the difference in positions. So that looks okay now, I think. I don't see anything else going completely crazy. Let's have a look. Yeah, I think that might work. Let's try it. Let's run our program. Well, it stopped the infinite error. We can walk. Can we jump? It's the moment of truth. Yes, we can jump. So I'm going to try and go towards a platform. We do land on it. Excellent. I'm going to keep jumping. Ooh, this is far. I don't know if she can make it. Again, you might have to move the platforms around until she can actually make the jumps. But we're getting close. Excellent, we got to the start. Now, of course, this just has a black screen. In a proper game, you'd go to the next level or have a victory menu, but of course, we've got to keep the tutorial relatively short, so we just had our way.clear scene condition when we collided with the star. Here it is in code there. So this looks like everything works, and that is how you make a very simple platformer. Thank you for watching.